All right, good morning, guys. Let's do a quick visual and audio check. If you can hear me and see me, give me a thumbs up. All right, thanks so much, Tara. All right, you guys did pretty good on your test overall for the most part of you. Most of you guys did pretty good, and that was chapter 5. Now we come to chapter 6, which is your last chapter of this course. I hope you guys have learned a lot this year. And this is us coming to our last chapter. If my memory serves me correct, there should just be 3 lessons in this. I think 3 lessons, yeah. 3 lessons, and then we will be done with chapter 6. And then the only thing, you'll have a chapter 6 test, and then you will have a you would then have a final the last week. I don't know what the final schedule looks like currently. They're telling us tomorrow. We have a faculty meeting tomorrow, and we'll find out in that faculty meeting what the final schedule will look like. But I can tell you your final here will be a multiple choice test on Canvas, similar to the ones we've taken the past 2, but it will be over everything we've done thus far in the class. Okay, so just letting you know that. And then next week's schedule will be a little bit different to accommodate that. Accommodate chapter 6 tests while at the same time giving you the study guide for the final. Once I hear more about the final scheduling tomorrow, I will then give you guys some more information about what next week's schedule looks like. This week, everything's normal as usual, Monday and Wednesday to 12:45. Other than that, I think that's it in terms of all that. So let's just let's jump in here. Let me get a couple pins here. Let's just jump straight into this chapter, chapter 6.1. Now, chapter 6.1 and chapter 6 is all about exponential graphs. Okay, it's all about exponential graphs. So give me 1 second. Chris says I can't see. What can you not see, Chris? Can everyone else see? Tara, can you see? Okay. I'm assuming that'll work out for you. Good. But chapter 6, okay, is all about exponential and logarithmic equations. Okay, chapter 6. Chapter 6 is all about exponential and logarithmic functions. Okay? What we're going to talk about today is the exponential functions. Okay? An exponential function is any function of the form this. Y, or we know that can be f of x, is equal to a times b raised to the x power, where a and b are constants or just numbers, with a not equaling 0 and b being greater than 0, and b cannot be equal to 1. Okay? Now, you may be saying, okay, well, what is an exponential function? It's just another graph in our function graphs, guys. It's just an additional graph, okay, with all of our function graphs. We started the year with x squared, which we know is a parabola, x squared. Then we went to x cubed, which we know is kind of like the snake. Then we went to the absolute value of x, which is kind of like a v. Then we went to the reciprocal function, which is 1 over x. This last time we went to the square root function, the square root of x. We also did the cube root of x. Which is the snake kind of going sideways. So then today we learn the exponential function, b raised to the x power. Okay? So we have learned 6 so far. This will be our 7th one. Okay? This will be our 7th one. Okay. Now, let's jump into this, number 1. So it says, sketch the graph of each function, identify the domain, the range, the intercepts, asymptotes, and end behavior. I actually want to scratch out something here. I want to scratch out intercepts, asymptotes, and end behavior. I'm not worried about that. I just want you to find domain and range of each one. Okay? So we're going to sketch this, and then we're going to identify the domain and range of each one. Okay, so here we go. 2 raised to the x power. So just like we've done with every single one of these functions, I didn't start off by giving you the graph. We started off by making an x, y table. Okay? We start by making an x, y table for this. So let's just start with 0. Can someone type in the chat box, if I put a 0 in there for x, 2 to the 0 power, what would that equal? 2 to the 0 power. What's anything to the 0 power? Very good, Tara. 1. Very good. And again, that's just like 2 to the 0 power. If I put a 1 there, that's 2 to the first power, which is 2. If I put a 2 in there, that's 2 to the second power, which is 4. If I put a 3 in there, that's 2 to the third power, which is 8. Okay? But we also need to go to negatives. Okay, so let's go -1. Which looks like this, 2 to the -1 power. Who remembers what you do with the negative? Can anybody remember what I always said with that negative? I said do this with it. Can somebody type that into the chat box? What do you do with that negative? Yeah, kick it out. And whatever you have left, which is 2 to the first, put it under 1. So 1 over 2. So that would be 1 over 2, 1/2. Well, what about -2? That would look like this. 2 to the -2. Kick the negative out. Whatever you have left, which would be 2 to the second, put it under 1. 2 squared is equal to 1 over 4. 1/4. Well, the -3 would be 1/8 because you should see a kind of a pattern going there. And we have this right here. Now let's graph all these points. Let's graph all these points. So we got 0, 1. We have 1, 2. We have 2, 4. we have 3, 8. Now, I know I stopped at 3, 8, but if we wanted to go 4, 2 raised to the 4th power would be 16. So 4 all the way up to 16. I think that's the biggest we could go. Okay? But then over here, we have negative 1 and 1/2. Negative 2 and 1/4. Negative 3 and 1/8. Now, here's the thing. If we kept going here, guys, we're going to get closer and closer to 0 going down here, but we're never going to touch 0. No negative number is going to ever touch 0. So watch this. Even if I say 2 raised to the negative 10th power, 2 raised to the negative 10th power, now that e means times 10, so that means it's a number less than, it's a number extremely close to 0, but not quite there. Let me show you a better example. 2 raised to the negative 6th power. As you see, it's this right here, and that is a fraction, is 1/64th, and then it'll go 1 over 128, then 1 over 256. It's going to get extremely close to 0, but it's never going to touch it. Therefore, that is a asymptote, as we would call it. So the graph does this right here. It goes right down that line, but it never touches it. And then it hits all these points going up. Looking like that. And this is your exponential function, guys. Looks like this. You may be saying, well, where is this used at? It's used in the stock market, which is one of the biggest things. Stock market, Roth IRA accounts, retirement accounts. Some of you might have heard the phrase, that grows exponentially. Okay? That grows exponentially. And we would say that this right here, your money in a retirement account, prayerfully, it grows exponentially. Where it starts out, going a little bit slow, then all of a sudden it just starts building and building and building. Okay? If we were to talk about how you grow as a person, it would not be exponentially. You know what I'm saying? It might not be linear, which is just a pure straight line, but it's not as exponential because all of a sudden you don't just shoot up. Now, you may grow a little bit taller, like in over a span of 3 years, but it's not going to be like exponential where it grows. And keep in mind the word exponential. The word exponential comes from the word exponent. Because notice here, our exponent is the variable now. We're used to seeing this, x squared, where the base is the variable, but now it's the opposite. It's the exponent. Okay? So our exponent, or the exponential function, is something that increases very rapidly and never drops below 0. It can drop below 0 on certain things, but for the most part, you're going to see it like this. Okay, so then let's talk about the domain and range of this graph. Well, the domain is all the possible x values. So all these x values are here on the graph all the way to over here. So think this is negative infinity, this is infinity. And just ask yourself, where does this graph go? It goes from negative infinity to infinity. So from negative infinity to infinity is my domain. And then my range is up and down. So it goes from 0, but it never touches 0, all the way up to infinity. This way is infinity, so it'll go all the way up to infinity. It doesn't touch 0, so we put a parenthesis on it saying that that's not included. If 0 was included, if it was a part of it, we'd put a bracket. But since it's not, we put a parenthesis. It will never touch 0 at all. And that is the exponential function, guys. That is it right there. Okay. Does that make a little sense? Give me a thumbs up. You're with me? You follow me a little bit on that? Very good, Catherine. Very good, Tara, Jamie. Very good. Okay. So, our next, going over here, number 2. Let's look at this one. 3 raised to the x power. So, again, we start with the xy table. And I'm always going to start with 0, 1, 2, 3. Anything to the 0 power, so that'd be like 3 raised to the 0 power, is 1. Anything to the 0 power is 1. 3 raised to the first is 3. 3 squared is 9. 3 cubed is 27. And I don't think we'd have to go much higher than that. All right. Then from there, we want to go negative. Negative 1, negative 2, negative 3. 3 to the negative 1, remember what you do? You kick that negative out, and whatever you have left, which is 3 to the first power, put it under 1. And 3 to the first power is just simply 3, so 1/3 there. 3 to the negative second power, kick the negative out, and whatever you have left, put it under 1. 3 squared, and 3 squared is 9. 1/9. 3 to the negative 3, kick that out. Whatever you have left, put it under. 3 cubed, and that's 1/27. So 1/27. So I got 0, 1. I got 1, 3. I got 2, 9. I got 3 and 27, which would be way up here. Then I have negative 1 1/3. And as you see, guys, again, same thing here. I could keep going on and on and on. I'm just going to get closer and closer to 0, but never touch it. So I'm just going to draw a line like this, and it's going to go about like this. Okay? And that's the exponential function. It grows exponentially. And you may be saying, why do we say it's exponentially? Look, the exponent's the variable, so it's growing at a very fast rate. If you can think about addition growth is good. If you had 1, then doubled it each day, that's, adding, or that's multiplying by, 2 every day. But if you squared something every single time, that's going to get even larger and larger. So the best growth is exponential growth. And that's what this guy's right here, that you see this going from left to right, going up like this. So that's when B is greater than 1. When B is greater than 1, we're going to have what we call exponential growth. So we call this exponential growth right here. When B, you want to pay attention to this because you'll probably see this on the test. When B is greater than 1, we call it exponential growth. Something is growing exponentially. Something else that would kind of grow exponentially. I don't know if you guys have heard the story about the bamboo tree, but the bamboo tree, it can stay in the ground for up to 5 years and never grow. So if here's the soil, it can stay underground growing its roots for many, many years. Okay. But then once it starts to grow, it can grow up to 36 inches per day. Per one day, it can grow 36 inches. So that's what we would call exponential growth. It's very slow at the start. It's not growing basically none at all. And then all of a sudden it can just shoot straight up. So bamboo tree is a good example of exponential growth. All right, let's jump down here to number 3 and 4. And this will be it today actually. So f of x is equal to 1/2 x. Now notice this. When I said b is greater than 1 here, everything's in the form of y equals a times b. Now our a here is just simply 1. But look at b now. b is less than 1. It's a fraction. Okay, so let's see what that does. Let's create this xy table. And let's throw some numbers. 0, 1, 2, 3. Sorry, I'm not sure why it's not focusing. There we go. Okay. So again, this would look like this. 1/2 to the 0 power, anything to the 0 power is 1. 1/2 to the first power, which would just be just itself. Anything to the first power is itself. 1/2 to the second power would be 1/2 times 1/2, right? 1/2 times 1/2, which is 1/4. 3 1/2 cubed would be 1/2 times 1/2 times 1/2, which is, you just multiply numerators and denominators. 2 times 2 is 4 times 2 is 8, so that's going to be 1/8. So 1/8. Okay. Now we go with our negatives. -1, -2, -3. All right. Now, this is the way this looks. It looks like this. 1/2 to the -1. Here's what this looks like. Kick the negative out. Whatever you have left, put it under 1. So 1/1/2. Now that looks like this, guys. 1/1 divided by 1/2. And that's where that middle school math comes in. Keep the first one. Change your sign. Do the reciprocal. And you get that to be 2. Okay? Now, if you noticed up here, notice up here like 1, 2, 2, 4, 3, 8. I don't know if some of you caught on to this, but this was -1 was just 1/2, -2 was 1/4, and -3 was 1/8. So it's basically the reciprocal of these. You just flip it. Because think about that. I could write that as 2/1. So then -1 would just be 1/2. 4/1 or 1/4. So same way here. Since that was 1/2, just flip it over and you can get its opposite. So 2 was 1/4, so -2 would be 4. 3 was 1/8, so -3 will be 8. And that math, you could do that math just like we did that first one right there, and you could get that kind of worked out. All right. So then from there, let's plot. We got 0, 1. We got 1, 1/2. We got 2 1/4. We got 3 1/8. We got -1 and 2. We got -2 and 4. We got -3 and 8. And -4 would be 16. I didn't have that over there, so it looks something like this. It's going to get really, really close to 0, but never touch it. And then it's going to go up like this for a very, very long way. What's the difference in number 3 and number 1 and 2? What's their difference? It's going what now? Someone type that in the chat box. What's it doing? It's going... It's going left. Okay. If you're... yeah, and keep in mind, it's really going right because we read these, Chris, from left to right. So it's technically going right. But if you were reading it the other way, it technically would be going left. But technically it's going right. So they're opposite. So this is going down. Okay? But notice the reason it's going down is because B is less than 1. So when B is less than 1, okay, but greater than 0, let me write that, but greater than 0, so it's between 0 and 1, we get this shape right here. The opposite, as Tara said. And what we call that is we call that exponential decay. Okay? It's dying off, basically. It's decaying. Does that make sense? Give me a thumbs up. So when B is less than 1, when you see a fraction here, at B, at this A times B raised to the x power, it's going to be exponential decay. So if you're looking at 4, we should know automatically, and guys, the domain for this, I know I didn't do the domain for the other one, but the domain for this right here will be from negative infinity to infinity, and our range will be 0 to infinity. So very similar to those up there, okay? Now let's look at number 4. Now based on that number 4 is 1/4, I know that this graph should be doing this right here. It should be going down from left to right, not going up. It's an exponential decay because the B is less than 1, okay? So let's make an XY table. 0, 1, 2, 3. Negative 1, negative 2, negative 3. All right, let's get 0. 1/4 to the 0 power is 1. 1/4 to the first power is 1/4. 1/4 squared is 1/4 times 1/4, which would be 1/16. 1/4 cubed would be 4 times 4 times 4, which is 1/64. Okay? And now remember, these are the opposite numbers, are just the reciprocals. 4, 16. Sorry about that. 4, 16, and 64. I put 6 there instead of 16. So it looks something like this. 0, 1, 1 1/4, 2 1/16, 3 even lower than that. So it does that number right there. Never. I draw that line. That's just a rough sketch, guys. I know I'm hitting 0 there, but it never hits 0. It's just you're showing it's going out. And then I got negative 1 and 4, negative 2 and 16. So this is decaying very rapidly, very fast. Domain and range. Domain, still negative infinity to infinity. And our range from 0 all the way up to infinity. And 0 is not included because it doesn't touch 0 on the y-axis. Guys, and that's it for lesson 6.1 notes. That's the way the cookie crumbles today. And that's all exponential functions, okay? 2 things you need to know. You need to know what exponential growth is, what it looks like, and you need to know what exponential decay is and what it looks like. Your main thing, guys, is just knowing that when b is less than 0, it's exponential decay going down. When b is greater than 1, it's exponential growth or it's going up. If you can know that today, you're going to be in great shape going forward. Yeah, that was pretty quick. It was pretty quick. Short, simple, kind of to the point. All right. Any questions of me? All right, on your homework, hey, I want you to get the domain and range, but I don't want you to worry about any of the other stuff that I had listed there. So identify domain and range, but don't do intercepts, asymptotes, and end behavior. Don't worry about any of that. Okay? On your homework, do that. You just have 4 problems. Just do the domain range, graph it. Make sure you show your XY table, guys. Make sure you show your XY table, showing that. Make sure you understand all that. If y'all don't have any questions, give me a thumbs up, and then you are free to leave this lecture. Thank you so much for being here today. Again, if you don't have any questions, make sure, I can't remember, I think I told you to make sure you turn your work in by Tuesday, tomorrow, by 4 o'clock. I'm not 100% sure. Can someone confirm that? Is that what I said? Good, Jamie. Good, Catherine. Good, Tara. Okay. Very good. This one was short, but the one on Wednesday, it'll be a little bit more lengthy. So Wednesday's lesson it'll be probably be a little bit longer than this one. Okay. So that'll make up for this one being so short. Okay. If you guys don't have any questions, you guys have a good day. We'll see you later. I'll stay on here for a few seconds if you guys have any questions. I'm going to mute my audio though. Have a good day, guys.